At this point, you know, I'm open to all your questions, right? But when we'll have quizzes or exam, I cannot answer any of your questions. Well, unless you don't really understand the question, so I can try to explain you the question. But I cannot help you with the question, with the answering it, okay? Guys, please turn all cell phones off. Okay. Just give me one moment, please. Oh, it is on. Okay, good. So just give me please one moment. Don't know macOS that well. Oh, okay. Good. So it's recording already. Anyway, so last time we discussed system analysis, right? So today we'll cover briefly all other stages in system development lifecycle. And also just to give you an idea, right? So this course is an introductory course. It's a basic introductory course, right? So this whole thing, right? Well, at least a one stage or two stage. There can be a whole course dedicated to this, okay? And we have just a few minutes. So we just do this, you know, in a very brief manner, briefly overview this. But there can be several courses here. But for you, you know, it's important just to know some basics. So this is what we're doing in this course. We are learning the basics, okay? So if basics are hard for you, imagine how hard those things are for professionals, information system professionals. So anyway, system design. So before we talk that, well, basically in this first stage, try to understand what is the user needs, what are the requirements of the users, how good the current system is, what are current systems' advantages and disadvantages, okay? So now the next stage is, you know, the design of a new system. So you would design a new system. So what do? Well, first you have to do this logical modeling, so-called, okay? And this is what you will be doing in your project. Actually, this is where your project kicks off, okay? So you will do logical and data and process modeling, and you will do some other things from other stages, okay? So what is logical data modeling? So the idea is that you have some business, right? Your business is set up in some way, and there are some things which are important for you. Okay, for example, information about customers, inventory, sales, vendors, and so on. Okay, so logical design or logical data modeling, the idea is to choose those subjects, those things of interest to you, okay, and put them in a model. This is why it's called data model. So you want to model data that you need. Okay, so all this relevant information that you need in your business, you have to model in some way or another. And the way we model it, we use this anti-relationship diagram, ER diagram, which was designed by Professor Chen. Okay, so so what is ER diagram? ER diagram is a very simple thing. You have entities, which are objects of interest, and you have relationships between entities, okay? So for entities, you have rectangles. For relationships, you have those diamonds. So just like this. For example, suppose that you're dealing with course registrations, okay? So what you will need in your business model, in your logical model, you will need three entities, three objects of interest, at least three: courses, registrations, and students. Okay. So you have these objects of interest, right? So why did we put them here? So the idea is that, again, you want to choose things of interest which you want to model in your system. So we'll keep some information about courses, registrations, and students. Okay. So courses are in relationship with registrations. There is a relationship between courses and registrations, right? Which is denoted by this diamond here. Okay. So, if you read all things, it says that you have registrations for courses, and registrations are performed by students. Okay. So you have this word for and by. You can put anything here, whatever is meaningful. Okay. As long as it's meaningful, you can put not for registration. You can put here maybe R for courses. Okay. And here also you can put R, well, not R, made by or just by students. Okay, students, registrations are made by students, something like that. So in this logical data modeling, you just put your objects of interest, okay, and you want to model relationships between them. So use rectangles for objects of interest, use diamonds to model relationships between them. Okay. So this is something very simple, which we will discuss in more detail basically in the next chapter, today, in chapter 8. Okay. And we'll discuss it in much more detail. This is called ER diagram, entity relationship diagram. There is something called extended entity relationship diagram, EER. So the idea is not just to have, those, let's say, data items, okay, those data models, the data objects. You also want to have attributes for them. You also want to specify what kind of relationship it is. It can be one-to-one, right? We discussed last time. One-to-one, one-to-many, many-to-many, and so on. So you put more detail here, okay? So we'll talk about EER today, and you will see the examples of EER, and you will have to build an EER diagram for your stage 1. Okay, so those were logical data modeling. But not just data modeling, it's not just about data, right? So, so before we start, what is of interest to us? Okay, for what we like to have some information, which would be somehow captured, modified, processed, and reported, right? The next question is, so how do you process this information? Okay, so for information processing, we need yet another model, okay, called a logical process model. So first thing was about data model, okay. This thing is about data processing models. So now we want to have a model for data processes, okay, and there are many ways how to do it, how to describe those logical data processes. So one way is to use something called DFDs, okay, data flow diagrams. So what is DFD? Here. So basically, in DFDs you have slightly more notation elements. So you will have, actually let me show you here on this one. So you will have rectangles for external entities. You will have circles for business processes. You will have open-ended rectangles for tables, right, for data basically. And you will also have those lines, right, those arrows, which would show the data flow. Okay, so here is an example of a DFD. So this is DFD for that ER, this entity relationship diagram. So we had registration for courses are done by students, right? So now we know data, what we are interested in. The question now is, well, how the data would be modified and so on, right? So basically here we can see that you have students that are external entities, right? Like we'll talk about this later. They're also called agents. So for now it's just external entity, students. They would request course registration, right? So there is some information system here which is responsible for course registration, for processing of this registration. So whenever students request to register for some course, okay, basically a record would be added to registrations, okay, and the course availability would be updated. All right. So why do you think? Why do we add a record to registrations table? And why do we update courses availability? Guys, listen carefully. So you have a process, right, responsible for course registrations. Students request a registration, right? And supposedly his request is fulfilled. So if you want to register a student, right, so you have to update, to add a record to registrations table, and you also want to to add a record to courses or update courses, update availability for courses. So why do we do this? Yes.
Maybe if a teacher wants to change what days he teaches, or you have to change the availability.
No, not really.
Maybe one can be like a data file, like one is like the content, and the other one can be the dynamic changes on the file.
No, not really. So no, the answer is very simple. So again, guys, you don't think. Suppose this is an information system, right? Suppose you come to Rutgers, so you register for the course, right? So what should happen at Rutgers in Gantt information system, right? So first, we should record your registration somewhere, right? We should know that the student is registered for this course. This is why we add a record to our registrations table. Okay, in this table we have registrations for all students, for all courses. So if student is registered for a new course, okay, you will add registration information to this table, okay? Then suppose you have a course. Suppose you have this AES course, right? So we have 20 students in this course, right? But I think the maximum number of students is 30. So if 30 students register for this course, okay, the course will become unavailable. There will be more space for more students to come in, okay? So this is where, and you can do much more, right? So this is something very simple. But for you just to understand what's going on here, you have to imagine, this like information systems and what it does and what you should do. So you have to think, basically you have to question why that's so, okay? So you see something, right? You look at the system and you have to understand what is going on, why it is going on this way, can it be changed, can it be better, are there any problems, and so on. Okay, so student requests a registration. So if, supposedly his request is fulfilled, so a new information about this registration is added to our database, right? Course availability will change. So for example, we'll have a table with courses, right? And for each course, it will say, well, how many students are registered for this course? Who is, the instructor for this course? What is this department, right? And so on. So, and this information will be updated since you have more students registered for this course, okay? Finally, the system will send student his class schedule. So that's another thing. Again, so just as with ERs and EERs, today we'll discuss this in more details, okay? So we'll talk about this DFDs in a lot of details, and I want you to ask me a lot of questions later when we'll discuss this in details, okay? About this stuff. Good. So this ER and DFDs is not the only way how to basically model data and processes. Another way, which is very popular nowadays, is this UML, Unified Modeling Language. So what is UML? The idea is, again, this object-oriented programming. So basically, you represent your data as some objects. Data has attributes, right? So objects has attributes, and this objects has some methods, okay? So as we discussed in chapter 3 or something. So basically, you can do things with an object, okay? So there is an alternative way how to model all of these things called UML. So we want this UML in this course, okay? But you can look at the examples in your book, and this is something useful. And there is not just UML and ER. There is this BPMN, business processes notation. There are patternettes, so there are many, many things. There are many ways how you can do this, okay? But probably this DFDs and ER, maybe UML, they're the simplest. So this is something good to know. Okay, so now you have this design, logical design, okay, data and processes. So what next? Well, then you have to think about physical design. What is physical design? Remember last time I showed you these tables, okay? There were tables, there were those primary keys, foreign keys, all this stuff, right? So we discussed this. So the idea is to take DFDs and to take ERs and convert them into tables, into forms. Last time there was an example of a form, right? Screenshot. We'll talk about forms later more. Into queries and so on. So this is something. So in your course project, you will have to do this, and you will also have to do this, physical design. So you'll do both. And we'll discuss again physical design in more detail. But just to let you know, so basically you think, okay, so I want to implement. So ER and DFD are not, basically tied to any approach in a kind of information system. So if you want to use relational database approach, for example, so you can easily convert your models to relational tables. Okay. So in this physical design, the idea is that you have, you build these prototypes, still prototypes of tables, of forms, of queries, and so on. Okay. You don't implement them. You just think of a design. So you write them on a paper, for example. This is what you will do in your project stage number 2. And then you will actually implement this in Microsoft Access. Okay? So this is the implementation stage, which we will discuss in a moment. So you have this logical design, you have physical design, right? Then what? So, and basically when you do this physical design, you integrate EERs and DFDs. So you have to tie them in. Again, we'll discuss it more later. So I want to go quickly through this chapter since the 8th chapter is more important, I think. And then there are another 2 steps in this process, in this stage, is to document everything. So you want to document each step, how you created the models, okay, both logical and physical, how you integrated EERs and DFDs. You want to document your designs, right, your forms, your tables, queries, and so on. So everything should be documented very, very well. Finally, as previously, we discussed this feasibility analysis, right? So after each stage of system development lifecycle, you do feasibility analysis. So first time we discuss, well, first you do this current systems analysis, first stage, right? And we discuss basically this, remember, NPR, net present value, right? IRR, internal revenue rate. So interest rate return, I'm sorry. So basically here you also have to do this feasibility analysis. So each time when you do some stage, you know more and more about your new systems, okay? About your new kind of information systems. So it means that you have each time, you have more information, you have a better picture of what will be at the end. You have to think whether it makes sense, whether it is feasible to implement such a system or not. Okay. Well, okay. So this is feasibility analysis. Then we come to systems development. So if everything is fine and your feasibility analysis shows you that, well, you have to proceed. Okay, you have to do the system. You have to implement this. So you do the system development. So what is systems development? So basically, what you had on papers, those tables, so you had these tables, you have queries, you had these forms, right? So you have to program them in your database management system, okay? So you create data structure, so you create tables, right? Table names, you designate those primary keys, foreign keys, things we discussed earlier, okay? And you also create queries and so on. At this point, what you also do, you can incorporate this data validation rules, again, which we discussed last time, right? So there was this range checks, for example, right? Valid combination checks, and so on and so on. So you can also do it at this stage. Detailed programming basically means that you create those kinds of forms, right? Those user interface. So you want your users to operate with the system, so they have to have some way. They will not go, into this database level and work with the system. They should have some simple user interface. Okay, and detailed programming is basically what makes it possible. Questions? Good, good. Again, we go here very, very, very fast. Okay, so suppose that you have your system developed, right? Before you actually start using it, you want to test it. So how do you test a system? Well, one way is to run some data for which you know the output, right? So you take some data as an input to your new system, and you already know what should be the output. And you check whether the output is the same which you expect it to be or not. If not, well, probably there is some errors, there is some bugs, so you have to correct this, right? So this is called using sample data. Okay. Also, what you may want to do, you may use the old system, current system, and you may use the data from the old system and feed it to the new system. Okay, and this would kind of simulate the current user environment, so they can test this system in a current user environment, what's going on right now. Okay, so users will look and see whether this system operates as intended. Okay, so and as I just mentioned, well, probably at this stage you will need users to use it, since there are people who use the system, so they know how to use it, they know what to expect. So you would like to involve them in your testing. Next stage is training. Okay. So in the book, training is described very vaguely, right? But actually this is a big problem, training. Okay, it doesn't seem as so when you read the book, but this is a huge problem in training. So imagine you are a huge company, you just implemented Microsoft. You just implemented a new ERP system, right? Or you want to implement a new ERP system. So the system is radically different from what you have used before. So what do? You need users who would operate the system. So what do you think? What would you do? How would you train them? Set up a class. So one way is to set up a class. Okay. Here's the problem. So who would be working on the current system? What do you mean nobody? Yeah, but you have business running. You cannot just take all the users from the current system and train them, set up the classes for the new one. Okay, they're busy, they have work to do, right? Train them in sets. Okay, one way is to train them in sets. Okay, would you pay them for training? If you assume that people work right on the regular job and then they train, right? So will you pay them extra? They spend more amount of time. Why not? You wouldn't, right? But they spend more time in training. or they do more stuff. Yes. Well, suppose okay, you have a job, right? You work from 8 hours, and then you have this training which will take another 2 hours. So it's not 8 hours; it's now 10 hours. Yeah.
So 10 hours in a day?
Yeah. For example. So basically, well, there is some cost associated. First cost, well, basically, if you decide not to use their, the job time and to have them train in some extra time, well, you have to pay them, right? So if you decide, well, basically, they have 8 hours, okay, let them work 6 hours, and let them train for 2 hours, you incur some cost, right? Since, okay, there is some cost to it. So anyway, this is costly. Okay, so suppose you want to do training. So when would you do training? When would you train your users, your employees?
I guess it'd be whatever's best for you, whether it be the 6 and the 2 or the 8 and then the time for half.
No, I mean, at what time, right? Not at what time, at what period would you train them? At what business cycle, I would say.
With development stage. I would train the managers first and then
You'd have to train everyone, basically. I guess what I was trying to say that, so when you train your users, right, you would like to train them when you don't have a lot of business activities, right? So if you have this business which operates in cycles, for example, you get more orders on Christmas, right, or Thanksgiving, right? So you would train your users, say, during the spring or something like that. So you have to think when to train them. Again, it can all introduce a delay to your thing. Okay, then suppose we know when we want to train the users and how to deal with the extra hours of training. The question is, where would you train them? So again, they need some probably special facilities, right, to be trained, right? So there is a huge logistics problem, how to do it. Okay, so suppose you decided on this. So how do you know if your employees actually, learn? If you just don't, if they do something during this training, they listen hard, just like students, right? So, yeah. You want to give them assessment? Very good. Right. So just like students, right? So you come to class, right? I have no doubt that many of you sit on Facebook, right, during even this lecture and many others lectures, right? So don't pay attention. But at the end, you have a test. Okay. So and university tests, well, are not that hard. Okay. It is much worse when you have a job. You know why? People are more demanding, and if you get fired, you get fired. You're not paid, and it's hard to get a job, to find another job. Let's put it this way. Okay. So it's much worse, so you have really to work hard if you want to keep your job. So training is a huge problem, very expensive, and very traumatic for users, and so this is something to deal with. Okay. Then again, so when you have some system developed, right? So you test it while it works fine. You train your users. Again, you will run this feasibility stage. Okay. So is it still feasible? Maybe your users are not trained. Maybe they cannot use the system. Maybe something needs to be changed. You found some problems during the testing, right? So what do you think? Well, does it make sense to proceed or no? Maybe I should go back. Maybe I should cancel this project. Okay, maybe it costs too much. So that's another thing which you should do. So you always do this feasibility analysis at the end. Okay? Good. Well, suppose you've done the system analysis, system design, and development. So you actually want to implement the system. Again, it's not that easy. Well, one thing is data conversion. So remember last time we discussed those old file-based systems. And what was the problem with those applications, those file-based applications? Do you remember? These couple programs. Very good. So essentially, you had two programs, okay, which should have used the same files, but for example, inventory file, right? But each program had its own inventory file. And one problem would be that they may not agree with each other, right? There may be inconsistencies among files. So now suppose you want to transfer your current data to this new system, okay? Well, one thing is to convert data, but suppose this is not a problem. There are applications which help you to transfer data from old to new one. But you have possibly several, say, files of inventory, and they are not consistent with each other. Okay, so what do you do? So you have inventory, so, well, even forget about inventory, maybe it's easier. Let's say customers, right? You have two files. Well, you have many applications, old applications, and there were 2 or 3 files with customers, and customer information differs. For the same customers, they have different addresses, different phone names, right, across different files. What do you do? Well, you can contact customers, right, and so on. And probably there are people that use the old system which know what is the right information. Okay, so there are those people who, you know, basically know what to do at the situation. So, but still, this is a very painful process. Again, it's not mentioned really in your book, but this is a very painful process, data conversion, and it usually costs companies a lot of money. Okay, so actually, due to this drawbacks of the old file systems, or of the old applications that we discussed previously. Okay, so this is also a huge problem. Okay, so systems conversion. Okay, you have the current system, you have the new one, right? So actually, I think we discussed it briefly last time, but how do you switch to a new system? One option, okay, is very radical, which I told you about last time. It's called turkey. Okay, sudden switch. So today you use an old system, tomorrow you use the new one. That's it. And I told you that for Hershey's it was a huge problem, and it cost them, I think, even billions of dollars. I'm not sure. I have to check. So for Hershey's, this first option was a disaster. So when they implemented it, they lost lots and lots of money, and they sued SAP and so on, but it was too late. Okay, so what is the problem here? The problem here is, well, if you have a new system and you want to suddenly switch to it, first of all, it may be buggy. There may be errors, right? If there are errors, they can propagate. And do you know what is one of the problems with this automation? So Alex, I think you will maybe discuss this during your audit class, but suppose that in the old days you would have a fraud, right? And where there will be no computerized system, right? So you would have, say, someone stealing your assets, okay? So usually those people cannot steal that much. Okay, well, they can steal something, but you may not even notice it. But if you have, say, hackers which rob banks, right? They can steal a lot. Do you know why? Yes, because the system is automated. Okay, you don't have to do it physically. You can write a program which would rob 10,000 banks or something like that. Okay. So this automation is a big deal. So there are some benefits, but the drawbacks is if there is an error, it can corrupt everything. Okay, all your files, all the data, it can stop your business, and it can be huge losses. So so if there is an error with this new system, you may lose a lot. That's one problem. Another problem is, again, you have users, right? Which, well, okay, they were trained, but still, they may not feel comfortable using a new system. What sometimes happen, right? So even it may happen to you. So suppose, again, you take this course, right? Then you go for a real job as an auditor, and then, well, basically you see these databases. What would you do, right? First, at least at the beginning, you will be astonished, right? So you would not know what to do. Okay, you'll be overwhelmed. This what can happen to people. So there can be again huge loss due to inability of people to operate with the system. Okay. Of course, there'll be something like call center set up, right? So if there are any problems, you would call to call center. You would try to, to get some support, but still, this is a very, very radical thing to do. Another idea is parallel conversion. So, basically, as it says, you run two systems in parallel, the old one and the new one. Okay. So while you still use the old one, you start using the new system. So what do you think? What are advantages? What are disadvantages? You have the old system, right, which you have been using up to date. Now you have developed a new system, and you use them simultaneously.
What's the question you're asking?
What are advantages and disadvantages of such approach?
Disadvantage, maybe it takes a lot of time.
Yeah, sure, of course. You have to say process more to enter, twice as much data, right, as before. Okay, so there is some cost. Okay, and it's not just it will take long. Again, users may be confused. Another thing which is a problem here is, so what we discussed before, if you design a new system, right, you may change your business process. So you may do things which you haven't done before, okay? And this will not be, just doing the same on a new system. This may be doing radically different from what you did before on a new system. In the same time, when doing the same stuff you did before on the old system. So users might get confused. Okay, so it's costly and it's a lot of confusion. Advantage is that, again, you can test system better, right? If there is an error, you can find it, and your data is still intact. Okay, since you're using the old system. Finally, phased-in conversion, right? Something that Rutgers did, for example. So the idea is that, you have this business cycles, right? And you basically use a new system cycle by cycle. For example, today you start using new sales system, okay? In months, 2 months, year, you start using the purchasing system, right? And so on. So you basically implement new system cycle by cycle. Okay. So what are advantages? What are disadvantages? What do you think? Sorry?
You said disadvantage, right?
Yeah, what is advantage and disadvantage?
I was going to say storage space because you're working on two systems, so storing data.
Well, storage now is cheap. Okay, so. But, okay, suppose that you were using an old system, right? And you have all these business cycles operated by the old system. Now for your sales, you start using the new system, just for sales. But, this sales cycle is not disconnected, right? We discussed this. So all business cycles are connected to each other. So you have to connect somehow. You have to create an interface between the old system and the new one. So again, it is costly, right? Okay. What else? So cost is one thing. You have to create these interfaces between old and new systems. What else? Yeah, it may be. So users again might get confused, right? And again, just as before, they might be, you can do with a new system, you can do things differently. Okay, so the old system and new one can sometimes are not compatible. So it's great if you can, if you can create this interface between them, but they may not be compatible at all. Sometimes, and sometimes it is not possible. What is the advantage or advantages? Well, say compared to this cold turkey switch. again, control, right? So you can control more, right? So if you do it, in small parts, you can control everything better. And also, well, again, it's Rutgers. So one of the reasons why we implemented basically this our system, part by part, right? This phase-in conversion is due to the high cost of such a system. So okay, so well, today if you have money, it's a state university, right? So we're not that rich. So today we have money, okay? So today the first thing that we implemented was a payroll system, I think, okay? This HR, this HR system, REAs, it's called at Rutgers. Okay, the next thing we implemented, I think, was general ledger, and so on and so on. So again, we got more funding. So in next year, well, we'll do this. So basically, you can do it, whenever you have funds for it. Okay, and also a great thing about it. So if you want to convert old system to a new one, and you should show, say, managers, this works really well, right? So first you will choose those business cycles to convert for a new system, which will give the most benefit. Okay, so you will use this, idea of low-hanging fruit, right? So some cycles would benefit more from new systems than the others. So you can do that. Okay, so you have those three options for system conversion, and again, you have to have this source documentation. So how you converted the data to the new system, how you do the system conversion, and so on. Okay, so everything should be very, very well documented. If you have the system, right, so you should design these user manuals. So users should know how to use them. So they should, have these manuals. You should have manuals for system maintenance. Okay. And basically everything that goes into operation. So you should have all the documentation out there. Good. So the final stage is systems operation and maintenance. So I'll be quick here. So basically, what is systems operation maintenance? Systems operation means that you are, basically you start using the system, right? You implemented it and you now operate it. You use it. Okay. Then there's maintenance. So what happens at first when you use a system, it will there'll be some errors. How hard you try to avoid the errors, they will be there. There will be bugs. Okay, so you will have to deal with those. So there is something called corrective maintenance when you try to trace all those errors in the system and correct them. So it may take, say, a few first months of operation. Once you have eliminated all errors, right? Then you will do something called perfective maintenance. The purpose of perfective maintenance is to improve the system. So the system may be slow due to some bottleneck, right? So you may deal with this bottleneck and you may make your system faster, okay? So you will improve performance of the system. So this is called perfective maintenance, okay? So once your system is operates, there are no problems with operating, right? So corrective and perfective maintenance was performed. Now you would like to basically get some knowledge about the whole process. Okay, so you would like to get the knowledge about this development process. You would like also to get knowledge about system. So that, for example, naturally managers, if you implement something new, right, and it works, so managers would ask, well, does this system, really delivers what was promised, right? Does it work very well? Is it of benefit to us to use the system, and so on? So all this will be examined and reviewed. It's called post-implementation review. Okay. So again, quickly about this. So, this system development lifecycle, right? So this is a methodology, as we discussed before. It's a methodology which was developed in 50s and 60s mainly. Okay. So this is a very, very rigorous methodology. It works very well. The problem with this methodology, it takes a lot of time to implement a new system using this methodology. Okay, very good methodology, but take a lot of time to work with this. Okay. So first of all, so how can you deal with this? First of all, you want to track the progress, okay, of your development. And there are two techniques to track the progress. One is called PERT chart. What is the PERT chart? So I think you have started before PERT chart. Have anybody seen this before? Okay. Okay. So in your operation management class, you should have learned this. But anyways, the idea is that, okay, you have this system, right? You have this plan how to implement this. You have the stages which we discuss. Some stages can be done only sequentially, one by one. Okay. Some things can be done simultaneously. So here you have 5 stages, okay? And what this PERT chart says is that, well, first you have to perform requirement analysis, okay? Then you have to conduct systems survey. However, at the same time when you conduct system survey, what you can do simultaneously, you can do the third step. You can perform feasibility analysis, okay? Then, after you've finished 1, 2, and 3, you should develop ER and DFD models, okay? You can't do it sooner. First, you have to complete stages 1, 2, and 3. Finally, you have to integrate models, okay? This is the 5th stage. So, so it basically tells you what is a sequence of the stages, what are the stages itself, right? Themselves, and what stages can be done simultaneously. In parentheses, you can see numbers, okay, in parentheses for each stage. So the number indicate, at least in this case, indicate a number of weeks that takes to complete, each stage. Weeks, months, years, well, depending on the project. Let's say here weeks. So for the first stage, you need to perform requirement analysis. You need 2 weeks. To conduct system survey, you need 3 weeks. To perform feasibility analysis, you need 1 week. To develop ER and DFD models, you need 6 weeks. Finally, to integrate models, you need another 3 weeks. Okay. And there is something called critical path here. Critical path is the longest path as defined in these weeks. Okay. So if you look just at one path, right? So basically here I have 2 passes. 1, 2, 4, or 5, and 5. And the other pass is 1, 3, 4, 5. So the critical pass is a pass for which the sum of those numbers in parentheses is a larger one. Okay, the longest pass. So what is the longest pass here? 1, 2, 4, 5, right? Since 2 plus 3, 5 plus, well, 6 and 3 give you 14, right? If you take the other pass, 1, 3, 4, 5, this would be what? 11, right? 12. I'm sorry, 12, right? It's 2, 1, 3, 9, 12. 12. Good. So what? Again, question to you. Why this pass is called critical? What do you think?
You have to do it in order for it to be done, right? Otherwise, your implementation won't work.
Yeah. So basically, what Matt is trying to say, that basically, yeah, this is something that has to be done. Okay. Okay. And if, well, everything has to be done, but if, say, number 2 will be delayed, okay, by some time, everything will be delayed. So if there are any delays along the path, then the whole project will be delayed. Okay. And while the chart is useful, well, you can do some stuff here. For example, you have this conduct system survey, which takes 3 weeks, and you are allowed simultaneously to perform feasibility analysis, which takes 1 week, right? So what you may want to do, you may want to say take more people who are working on feasibility analysis and task them to conduct system survey. Okay. This way, this system survey, you can reduce the time, say, up to 2 weeks, and you will increase here times maybe, again, up to 2 weeks. But your overall project time, right, duration of your project will be reduced by 1 week. Okay? Yes?
So does that mean, like, with the critical time, does that mean stuff number 3 is not essential to be done? Otherwise,
No, this is, you have to do it, right? But you are more flexible here, right? Okay, so you have this 3-week window, right? So you can do it in the first week, you can do it in the second week, or in the third one. So, you are more flexible here. If there'll be any delay here, okay, suppose your feasibility analysis will take not 1 week, but 2 weeks. That's fine. Then still, this will take 3 weeks, okay? So even it will take you more, you can, no big deal.
so your priority would be
Yeah. So if this will take longer, this is a problem. Duration of your project, will increase. Okay? If there'll be delay here. Okay? Guys, is this clear? Good. So this is this PERT chart, right? Another thing is this Gantt chart. So here's the Gantt chart, how it looks like. Again, so you have those, say, stages, right? And here for each stage you have a bar here. And the bar, it basically, so when you before stage is even initialized, right, before you start working on a stage, the bar is empty, it's hollow, right? When you start working in the stage, it will, the bar will fill up. Okay, the more it fill up, the more work is completed for this stage. Okay, so you can basically track the progress of your stages. Okay, what has been done, what hasn't been done. So how many % of test calculations have been completed so far, and so on. So it allows you to track the current progress of all stages. So this is the advantage of this Gantt chart. Okay. Questions? So the idea is, so this one basically gives you a kind of this more sequential approach. You can see what is in the sequence. You can elevate critical path, right? But it doesn't show you, how much of each stage has been completed. Okay. Here you see, again, you can see all the activities, how much time it takes to complete them, and you can track the progress of completion of for each stage. Okay. So very simple. Questions? No. Okay. So as I told you, this system development life cycle, this methodology is, takes a long time to do, right? Very rigorous, very great, but takes a long time to do. Especially nowadays, you want to do everything much faster. Okay, so no time to wait. Okay, so it's business, money. You want to do everything very fast. So how can you speed up the process? And there are ways how you can do it. One way is to use a special software. Okay, and this software, what it does, it tries to automate something. Okay, so less work is needed. So there's something called computer-assisted software engineering, CASE. Okay, computer-assisted software engineering. So the idea is that you have some people, say, working on ER and DFD diagrams. Okay, so they work on this, right? They're designing it. All the designs would be stored in a special repository. Then people who would, say, implement those designs, okay, they would use this repository to implement this. And as someone works on ER, simultaneously they can say do the physical design or implement the design itself. Okay, so in a way you have a better access to information by different people from different stages, so they can do it faster. Another thing is integrated case, which is even better than this case. Okay, so what it does, so if you create this ER diagram, right, it automatically creates, and DFD it automatically creates a table for you, right? So you don't have to write the table, design a table. It will do it for yourself, for you. Moreover, it will it can also do the implementation of the table. It can create a table structure in your database management system. So again, you automate things, okay? So you just do the design, and most of the things will be done for you. So you don't have to do, well, basically it reduces work that you need to do, okay? So one way is to use special software. The other way is to basically change the way you do this methodology, okay? One thing is called rapid application development. So we said that, well, basically you should do all those steps in sequence, okay? Here's the idea is different. Here they say, well, some things you don't have to do in sequence. You can work on some things simultaneously. So you can perform basically the current, well, say analysis of the current system, right? Simultaneously, you can work on a new system, right? At least you still have some idea what should be the new system, what should be there, right? It's not that you are clueless. Okay, so you know what should be more or less new system. So you can basically do things simultaneously. You can work on several stages simultaneously. This is the idea of rapid application development. Joint application development. This is another idea, okay? And you can use both. You can combine them. In joint application development, the idea is to have users more involved. So you have users involved in all stages. You get the feedback all the time from them, okay? They work more with you, so you will track problems or needs faster, okay? So you'll be able to do the job faster, okay? So you'll have this constant feedback all the time from the users. So one kind of instance of this joint application development is called prototyping. The idea is, well, you know, even before you do everything else, you can come up with some prototype. Okay, you can create a sample, you know, a demonstration of what the final system may look like. So first you will get some knowledge from the users, what they want, right? So you will learn users' requirements. You will create some prototype, some demonstration of your future system. You will show this prototype to your users, right? So they will either like it or not, accept this or not. If they don't accept it, well, again, you talk to them, you get their feedback, you redefine your prototype, okay? You change them according to their needs, what they want. Okay, again, you ask them, well, do you like this or not? Does it work for you well? And again, they can yes, say or no. So finally, when you're at some point, your users, well, they should be happy with prototype, and then you will finalize it, okay, and this you will use as a basis for your new information systems. Okay. Questions? So again, simple idea. So you do a prototype, right? So you show some preliminary, right, program to users and ask them whether they like it or not, whether they satisfy all users' needs. If yes, great. You work on this, okay. Still have to tweak things more or less along the way. If no, well, you define prototype until they like it. Okay, good. So so what we discussed up to this point is the idea that you basically build a system from scratch. But the truth is, you don't have to do it. You don't have to build a system from scratch. You may buy what called, you know, those off-the-shelf packages, right? So, and we already discussed this, right? So we said that you have the specialized accounting software, you have this low-level accounting software, right? QuickBooks Pro, Peachtree, and so on. You have this mid-range packages, Microsoft Dynamics, and so on. Sage, right? You have high-end packages, SAP, Oracle. Okay, so you can use those. You don't need to develop system from scratch. So, but the question now is: suppose you want to go with, you know, any of these, with some software, right? And well, and of course, so if you're a huge company, Microsoft, you will use a high-end package, right? If you work in a brick and mortar store, you'll probably need a low-end package, and so on. So suppose you know this, what kind of package you want, at least from what category. But still, you have a choice between SAP and Oracle. Okay. So how do you choose? So the idea is to understand what your needs. Okay. So you as a company have certain needs. So you want to see which software addresses your needs better. Okay, in the best possible manner. So you look at the package features, the support, and so on. Okay, quality of a vendor. So if you have Oracle, bless you, you have Oracle support. Well, suppose that Oracle will go bankrupt soon, and you know this, right? So do you want to deal with this software? No. Okay. So you take many things into account. So first you have this basically requirements. You think what I want from this, right? What are my requirements? Then you try to collect information about the software. So you go online, you look for there are special forums, right? You talk to people in other industries or in the same industry, right? So you learn about what things are there and what are the advantages and disadvantages. Okay. Finally, you create something called vendor selection matrix to make your choice. So what is a vendor selection matrix? This is something that you can see on your screen. The idea is that you have this criteria, like these features that you want to have, right? You have these features. Then you assign for each feature a weight, how important this feature is to you. For example, adherence to RPF instructions is 20%. Project understanding is 13%. So for each of these, you basically assign some weight. So the more points you put to a feature, the more important it is. Okay. Then suppose you have 3 vendors, just like here. Each vendor either supports this feature, or doesn't support it, or has a high quality support, right? So you have kind of on a 3 scale assessment of each feature for each vendor. So you fill this up based on information that you found online or found from other sources. Okay. Then you calculate a weighted sum of those, right? So the maximum points you can get here is 100, right? And then you calculate the weighted sum. Guys, how to calculate weighted sum? Do you know how to do this, right? How do we get, say, number 16.7 for feature number 1 for vendor 1? No. So the weight is 25, right? This vendor, you have this criteria, and you think that on the scale from 1 to 3, the quality of this feature is 2. Okay. How do you get 16.7 from this? 25 and 2. You what? No. So the way to think about it, so you can get 25 if you have 3 points, just like here. Okay. But you don't have 3. You have 2. Okay, so this number should be lower, right, than 25. So why it's 16.7? Yeah, basically I had to do like a proportion, right? So the 25, right? Suppose that here you have some number. Let's call it x. No, not 2, but x for now, right? This 2, right? You know that the maximum is 3. Okay, so you have to kind of normalize it, okay, to 3. Okay, so if you will have 3, it will be 25, right? 25 multiplied by 3 divided by 3 will be 25. If you have 2, it will be 2/3. 2/3, okay, like this. So 25 multiplied by 2/3 will give you 16.7. And then you average those, okay? And this is called weighted average. So I'm sure you have learned this before in your accounting courses, weighted average. Okay. Well, the principle is the same. Okay. So this is called the weighted average. So based on your weights and your scores, you calculate, those weighted scores, and you add them up to get the weighted average. And in this example, your analysis shows you that for the vendor 2, you get 81.67 points, which is the maximum out of those 3. So you would go with vendor 2. Okay. Questions? No. Yeah.
So that's the same way of price translation?
Yeah. So if you want to get, number 5, right? 15 multiplied by 1 divided by 3. So 15 multiplied by 1/3 will be 5. If you want to, for this, right, 15 multiplied by 2 divided by 3 will be 10. 15 multiplied by 2/3 will be 10. Okay, and so on.
It's divided by 3 because there's 3 vendors.
Yeah, because the maximum point is 3. If it was 5 scale, 5-point scale, you would divide by 5. Okay, so you divide by 3 since the maximum is 3. Excellent, strong, and weak. Okay. So the idea is, this weight is the maximum that you can get, right? So if everything is great, you can get 25. So everything is great only in this case, right? So he gets 25. Well, others should get less. Okay, and the question is how much less? So what you do, you multiply divide by, this 3, right? The maximum number of points, and you multiply by this weight. 2/3 of 25 will be 16.7. Okay. Good. So, are there any questions regarding this? No. Yes, guys, so let's make a small break until 8 o'clock, and then we'll continue with chapter 8. Okay? So, until 8 o'clock. So you need some equipment, for example, laptops, your computers, right? And finally, jobs are performed for clients, okay? So now we have 6 entities, 6 objects of interest: managers, professionals, skills, equipment, jobs, clients. For each of those things of interest, you will have basically a table, okay? You will keep information about them, okay? And then this ER diagram, entity-relationship diagram, shows how those things which you are interested in, how they relate to each other, okay? Through those relationships, through those diamonds, okay? So this is kind of a way how to describe a business. Well, they say, well, we have a CPA firm. In our firm, we have managers who supervise professionals. Our professionals have some special skills, right? So some are professional in taxation, right? So they some are great consultants. Others are, IT professionals and so on. So we have a job, right? So for the jobs, we assign professionals to those jobs. For some jobs, we need some equipment, which we have in our firm. And finally, we perform the jobs for clients, right? Okay? So this is kind of a story, right? You look at this and, well, you try to understand the business to some extent. Okay? Questions? Are there any questions at this point? We'll discuss, how we do this, right? But basically, now given that you have this ER figure, do you understand this figure? This is the question. I'm not saying, well, how we got this. I'm just saying, do you understand what it says at this point? Yes? Yeah. Good, good. Guys, any questions, please ask. Very crucial. Okay, so we can do more. This is, something very simple. It gives us something, tells us something, but it doesn't tell us everything, okay? So, we need more, actually, in our modeling. So what we need to expand this ER diagram with more information, okay? We need to add more things to it. So therefore, we have something called extended entity relationship model, called EER, okay? So again, we'll have these entities, we'll have these relationships, but now we'll have more information about type of a relationship, right? Remember last time we discovered if you have a relationship, it can be this one-to-one, one-to-many, or many-to-many, okay? This is called cardinality. So cardinality describes, these types of one-to-one, one-to-many, or many-to-many relationships, okay? So we'll practice with this. Another thing is optionality. So some relationship can be optional or not. Well, what does it mean? For example, you have managers and professional, right? You can have one-to-many relationship. Each manager would be assigned to many professionals, right? And each professional would be assigned to just one manager, okay? The question is, does a manager needs to be assigned to a professional or not? Is this an option or not, okay? It's called optionality. I will show you how it works. And it's the other way around. Does a professional need to be assigned to a manager? Yes or no, basically. Is it an option or is this not an option? This should be always true, okay? So I will show you examples in a moment so to easily understand. So basically we have, in this ER diagram, we disclose more information about the relationship, one thing. Another thing is that we have attributes, okay? So, for example, we have managers. What are managers' attributes, okay? So, just think of it like a table, like a field, right? What fields will you have? You will have manager ID, name, address, and so on, okay? So we will add this information into this ER diagram. And here's an example, right? So first, we'll talk about this cardinality. So you have two entities, managers and professionals, right? They are in relationship. So you want to describe what kind of a relationship it is. So first, let's talk about cardinality. This one-to-one, one-to-many, many-to-many, okay? So if you have something like this, It's called, well, they call it crow's foot. Okay, you have this crow's foot, right? This would indicate a many side of a relationship. So if you don't have this crow's foot, it says it will mean like one. Okay, so if you have crow's foot, it means many. If you don't have crow's foot, it means one. So in this case, it will say a relationship between managers and professionals is one to many. Okay, one because there is no crow's foot here, and many because there is crow's foot here on the side of professionals. Okay, so this figure says that relationship between managers and professionals is one to many, and the reason why it says so, when we look at managers, on the manager side, you don't see anything, you don't see this crow's foot. Okay, it means one. On the professional side, you see this crow's foot, it means many. So relationship between managers and professionals is one to many. Okay? Guys, question? If there was a crowd foot here and crowd foot here, right? Relationship would be what? What do you think? Many to many. Okay, so this means many.
So that is what?
Say it again. This means many. Okay, so if it would be many to many. If there were no crow's foot, right? No here, which would mean one to one. Okay? So again, there will be more examples, but just to give you an idea. Yes? Yeah, so yeah, exactly. So when you look at this EER diagram, right? So you have managers, professionals, so managers are supervised by professionals, and you have this many thing, right? This crow's foot here. So this means that managers are in relationships with professionals, and the relationship is one to many. So now, given what you know from chapter 6, right? If I ask you, what is the relationship between professionals and managers? What you should say? Many to one, okay? So direction is important. So managers to professionals, right? So the relationship is one to many. Professionals to managers, relationship is many to one. It's the other way around. Okay? Okay, good. So what does it mean here that we have one to many? Can anybody explain it?
Is that one manager can supervise many professionals?
Okay. And?
And a lot of professionals are supervised by one manager?
And one professional is supervised by a manager. So, the way how to read this, right? So please keep attention. How do you read this? Okay, so you want to read this, right? Well, let's start from the left. You can start from the right, but let's start from the left. So you start here, right? And you say, a manager can supervise many professionals, right? Okay? So if you want to interpret this many thing, you start from the opposite, right? You don't start from professionals, start from managers. A manager can supervise many professionals. Okay, now let's look at the other way around. Let's look at this thing, right? So you want to explain this cardinality, which is 1 here, right? Again, you start from the opposite. You start from professionals. A professional is supervised by one manager. Okay? This is the correct way to read this. Yes? Uh-huh. Again, this is important. Look. No, this means not many, it means relationship many to one, okay? Suppose today you have, as a manager, a professional, one professional, a means once, right? In English. If I say a rabbit, means one rabbit, right? So a professional, one professional, is supervised by one manager, okay? No, again. Let's do it again. You have managers, you have professionals, right? If there is no crow's foot, it means one. If there is crow's foot, it means many, right? So when you have this relationship one to many, for each relationship, there are two sides of relationship, right? So managers and professionals, and you have professionals and managers. So how do you read it? So two sides, like left and right, right? On one side you have one, on the other side you have cross foot. So if you want to interpret this cross foot, how to interpret this correctly? So you start from the left and you say A1. A manager supervises many professional, or a manager may supervise many professional. He may supervise one, actually, right? Should not be many, but he can supervise many if he wants to. Okay, a manager can supervise many professional. If you want to interpret this line, right, this one thing, one side. So you start from the opposite. So say a professional is supervised by one manager. Okay. Guys, question? Good, good. Again, we'll make more of this very soon. So do a lot of this today. So don't worry. So the next thing is optionality, right? So we had this, either cross foot or no cross foot. Now we add another element. Okay, so we add either this bar here, right, or 0. So in addition to cross foot or no cross foot, we add either kind of 1, right, bar, or 0, or circle. Okay. So 1 means it is mandatory. 0 means it is not mandatory. Okay. So, for example, let me show you how to read this. So you have managers and professionals, right? On the manager side, you have many, 1. Okay. On the professional side, you have optional, many. Okay. Okay. So you have here many, 1. Well, basically many mandatory, and here you have many optional. Okay. So relationship is, so this managers and professionals are in relationships. Relationship is many to many. Okay, many to many, and it's mandatory many on the manager side, and it's optional many on the professional side. And let me explain what it means. Basically, let's start with this one. So let's decipher this circle and cross foot. Again, you start from the opposite. You say a manager can supervise either 0, none, professional, or many professionals, right? Now, if you want to interpret this cross foot and this bar, this one, well, you start from the opposite. You say a professional must, this means, this is mandatory, must supervise at least, must be supervised, a professional must be supervised by at least one manager and possibly by many. Okay? Yes, you're next. 0 means that this is optional. Okay, so for example, suppose you have a manager which is newly hired manager, right? And he doesn't supervise anyone. Okay, so you want to allow in your business model, you want to allow this fact that you can have a manager which doesn't supervise anyone, right? Just new manager, right? No one was assigned to this manager. So you put here 0. So this 0 cross foot means, again, 0 cross foot. You start from the opposite. A manager can supervise either 0, none, professional, or many. Okay. So a manager cannot. He is allowed not to supervise anyone. Okay. Or he can supervise 4, 5, 7, 1, 12 professionals. Okay. This optional many, mandatory 1. Mandatory 1 means, again, let's start again. So you look at this, right? You want to interpret this. You start from the entity which is opposite to this notation, right? Which is a professional. So say a professional is supervised by at least one manager, right? Or possibly many. Okay. So he must be supervised by manager. So if you model your business like this, it means that, well, if you have a professional, he must be supervised by someone. There should be a case where you have a professional, and that professional is not supervised by a manager, okay? So in a way, we're trying to say when you model this, right, those things are very important, and they kind of define business rules. What is allowed and what is not allowed in your business, okay? Questions? So, yeah. There is a possibility of a manager not supervising a professional. For example, you hired a new manager, right? So, and you know, he doesn't supervise anyone. But say if you hire a new employee, a new professional, he must be supervised by someone. You must assign a manager to that professional. Okay. Questions? So again, so we have two things, right? We have either we have cross-foot or not. If we don't have a cross-foot, it means one. If we have a cross-foot, it means many. Okay. This is called cardinality, right? Cardinality number, basically, right? Then we have optionality. So if you have this bar, this one, it means mandatory. If you have the circle 0, it means optional. Okay. So questions? Okay. So as I told you, so in this EER, how it's different from ER. First of all, you have this cardinality and optionality defined for each relationship, like here. Plus, you have attributes defined, right? So for manager, you have here 4 attributes. You have manager number, name, office number, and email. The reason why this manager number is underlined, it denotes a primary key, okay? So basically, whenever you do this, one thing should be underlined, maybe 2. So it denotes a primary key. You don't need foreign keys, you don't need other keys, but primary key should be underlined. Okay. Then you also have professionals. You have professionals, you have 4 attributes for professionals: professional number, name, phone, and date hired. Okay, so professional number is also underlined. It means this is a primary key for professionals table. Okay. Questions? Guys, please ask questions if you don't understand this. So you have 2 entities here, managers and professionals, right? So again, how you read this? You have 2 entities, managers and professionals, right? So managers supervise professionals. So they are in relationship. Managers supervise professionals. Then you read this, for example. You say a manager can supervise either none or many professionals. Okay. Then you can read this crossfoot and 1. So, and you start again from the opposite. A professional can supervise either 1 or many managers. Is supervised by at least 1 or either 1 or many managers. I'm sorry. Okay. Then managers have 4 attributes: manager number, name, office number, and email. Manager number is the primary key for a manager's table. Professionals also have 4 attributes: professional number, name, phone number, and date hired. Professionals have primary key professional number. Okay. Yes, Sidra.
So the crossfoot on the left side, you have like a 1, right? That
Must be. So for each professional, there must be a manager.
There must be a manager, but for each.
And many.
Like for a manager, there must like.
For a manager, it's not necessary.
Have a
Yes, yes. So have a manager may not, well, you allow a manager not to supervise someone, right? Good. Questions?
Because she said, can you clarify what? The professional must be managed?
Yes, professionals must be managed. Managers don't have to, so each professional should be assigned a manager, okay?
That doesn't mean the manager will supervise.
But a manager may have no professionals assigned to him.
The manager may supervise.
Have no professionals assigned to him. He's allowed not to supervise you have a new manager, okay, coming to your business.
Manager not managing it.
Yeah, yeah. At this point, maybe he will manage later, but not today, okay? But if you have a new employee, you know, the new professional, then professional should be supervised by someone, right? You should assign right away someone. So whenever you create a record of your new professional, you should immediately assign a manager. Otherwise, you won't be allowed to create a record according to those rules, okay? So this is the idea, and again, today we'll see a lot of this, okay? So and we'll try to decipher this. So here basically have a very, very nice chart here which shows 4 possible cases from the perspective. So you have 2 entities, A and B, and there are 4 4 options for B, right? In terms of cardinality and optionality. You can have this kind of 1 mandatory, 1 optional, many mandatory, many optional. Okay, so let's try to read all of this. Yeah, Tamar.
You're gonna read it.
Yeah. Well, you can go ahead. So try to read this first one. This one, from that side, near B. Again, you start always with A. A. A must have B exactly 1. Let's say exactly 1. Whenever you say this, say exactly 1, right? Not many. Well, it says here associated, so you can say.
Because there's no crow's feet, right? It would be
Yeah, no cross feet, right? So we'll see example here. Okay, so basically it says here that A must be associated with exactly 1 B. Okay, this one. If you want to read this one, it says B must be associated with exactly 1 A. Okay, let's do the second one, number 2. So who wants to do number 2? Yeah, Gozi. Yes. Yeah. So yeah, this is correct. Yes. A may be or maybe not associated with 1B. Okay. Either it is associated with a B or not. Yes. Look if there is a crossfoot or not. If there is a crossfoot, then it's many. If there is no crossfoot, then 1. Okay. It's many. No. Okay. So if you have crossfit, it means many. Okay. If you don't have crossfit, it means 1. So at this point, you don't see a crossfit, right? So it's 1. Okay. Yeah. But this is cardinality. Then you have optionality. If you have this bar, it means mandatory. If you have circle, it's optional. Okay. So let's do number 3. So Sidra, so how would you read this? This one and crossfoot. Every A, let's say every A or AA or every A.
Every A is with 1 or many B.
So must or may?
Must.
Should be must. Okay. So it says mandatory, right? So say every A must be associated with at least 1 B. At least 1 B. Okay. So here it said every A must be associated with exactly 1 B. Here you say at least 1 B since you have many, right? Here. Yes, Tamar. Okay, let me read it. So again, forget about this left side. Let's look just only on the right side, right? Let's look at those. Those are always the same. So for A, if you look at this, it always says, for every B must be associated with exactly 1 A, right? But let's look at the B side. So the first case, you have this 1, right? So you say, again, you start from the opposite. You start with the opposite is A, right? Every A must be associated with exactly 1 B. We say must because we have this bar. It means mandatory. Okay. Why we say exactly 1? There is no many, no crossfoot. So it's mandatory 1. This is mandatory 1. Okay. The next one is optional one. Okay, optional one. So now you read, every A may be associated with either none B or one B. Yes, circle is optional. Then you look at this. You have mandatory many. Okay, again, you start from A. You say every A must be associated with at least one B and possibly many. Okay? So every A must be associated with at least one B and possibly many. So mandatory many. Finally, optional many. Okay, so how do we read this? Whitley. This one. Optional many. Every A. Yes, exactly. So every A can be associated with, well, either no B or non B or many Bs. Exactly. Okay?
Can be?
Yeah, it may be. May. It's not must. Okay? It may be associated with A. It may not. So you have this optionality. Okay? It's not mandatory requirement. Okay? It's not a necessity. So you don't require every A to be associated with B. Okay? Okay, so you have the circle here, optional. Again, we'll do it more today, so let's go on. But are there any questions so far regarding this? Good, good. So these are called EER diagrams, okay, which, as I told you, are used to model these objects of interest, right? So logical data. Then another thing which, again, we talked about today are those DFDs. So DFDs are used to model logical processes. So here you have just, well, basically what data you want to have. You want to have data about managers and professionals and how the data is related. But this diagram doesn't tell you anything how data is inputted into the system, how it is processed, okay, and how how reports are generated and so on. So no data flow here. Okay, you don't see data flow. So to have this data flow, we use DFDs. Okay. So we have four symbols DFDs. We have, as I told you, so we have process as a circle. We have external entity or agent as a rectangle. We have a table or data store, open-ended rectangle, and we have a data flow, which we depict with an arrow. So let's look, I think, an example. Oh, so first of all, there are many types of DFDs, okay? So, there are more high-level DFDs. There are DFDs which concentrate on, say, recording of information, on maintenance of data, and finally on reporting. So you can have kind of different types of DFDs. So we'll discuss four types, okay, of DFDs. So when you do your project, you have to do all four types. You'll have four different DFDs. Okay, so let's see. So first is a context diagram. So context diagram is something very, very high level. Okay, so the process here is basically your system, which you want to model, your whole system, right? For example, what we did, we had this example, right, where we had the system. And the idea was to record job and to assign jobs to professionals, right? So you have the system. The system has inputs and has outputs. Okay, you depict inputs on the left side, outputs on the right side. Okay, you have several entities here, external agents. Okay, what they call them: clients, professionals, and managers. Please take a note that basically clients and professionals are, basically doubled here, right? You can see them on the left side and on the right side. And the reason why we have them, on the left side and on the right side is because we have to keep inputs, those are inputs, separate from outputs, right? We could have, so basically, okay, let me just show you. So clients input job requirements, and the output are what? A job acknowledgement, right? So we could have drawn a line, from here to clients, right? So there can be two arrows, but it's harder to read this way. So we have inputs on the left side, outputs on the right side. Okay. So we have clients input job requirements, professionals input information about their skills and availability. Please take a note. You have this arrow, okay, and the direction of the arrow. It's one headed arrow, right? And it's kind of input. So data flows from clients and professionals to our system, to our job recording and assignment system. Okay, so this is also called a process. So then you have outputs on the right side. So what are the outputs? Well, you assign job to professionals, right? Again, take a look at the arrow, right? It's also always facing to the right. So you assigned jobs to professionals. So this is an output, right? You create reports for managers, and finally you create job acknowledgements to clients. Okay. Well, this is called, this is a high-level DFD. So we have just one circle, one process, and the circle depicts our information system. And our information system is designed to record the jobs and assign jobs, right? Okay. Context diagram. So all of you will have to do this context diagram in your project, stage 1. Okay, good. Then we'll talk about DFD level 0. What is level 0? So there can be several levels, level 0, level 1, and so on. Level 0 is when you look at the most important events, most important processes which happen in your business, okay? And you denote them, as high level, level 0. Then you can drill down and look into sub-processes. This will be called level 1 and so on. But let's start with level 0. So level 0, you want to show the most important processes, right? So, and well, they say, basically here you have two most important processes. One process is to record the job request. Another one is to assign professionals to the job. Okay, so they identified two of them. Maybe you can think of a third one. Okay, so it's more of an art, right? When you think about what are the most important ones, well, it's up to you, right, as a designer. So the idea is that, well, you have this, system, and you can see that, well, there are two main events in the system. One is associated with recording the jobs, and the other one is associated with assigning professionals. Okay, so how would you create a DFD for this? Okay, so this is a DFD. Okay, so you have two processes: record job and assign professional. Okay, so what's important here is sequence. So you don't first assign professional and then record a job. Usually first you would record a job and then you would assign professional, okay? So record job precedes assign professionals here, okay? And you can see that those processes, those circles are numbered. 1, 0, 2, 0, and so on. So 0 here stands for this level 0 DFD, okay? That's why I have 0. Level 0 DFD, so 1.0, 2.0. So level 0 will also always have, the 0.0. If you would have a third process, another circle, it will be, called, well, some name 3.0, fourth one 4.0, and so on. Okay. So record job and assign professionals. Good. So again, we have clients, we have professionals, and we have managers, right? So if we look here, we have clients, professionals, and managers. So in a way now we are looking, we are taking a more detailed look. This was kind of an overview of our system, what are inputs and outputs. Now we look slightly deeper. We look at the main processes which are taking place here. So there are two main processes: record job and assign professional. So how do we record job? Well, client basically said that we need to record a job, right? He gets the job acknowledgement here. By the way, when you have a context diagram, inputs on the left side, outputs on the right side, right? So here, job requirement is on the left side, input. Output to the system is job acknowledgement, right here. So when you have level 0, it doesn't matter. So whether it's on the left side, it's on the right side, inputs, outputs. So so you just want to make it neat, since there are much more things here. Okay, it's very hard to organize it, in a way where you will have something on the left side, something on the right side. So basically, if you have a client, you would, you can kind of go back, okay, to have those arrows facing left. You can have inputs and outputs to the same entity. So have clients. So clients request a job, right? And you have a process. Process access information about clients and add a job to the jobs table and acknowledge the job, right? Acknowledges that basically this process received this order for the job. Okay. And now you have another process to assign professionals. So this process access information about jobs, current jobs, okay, which are needed employee to be assigned to. Access information about professionals, access information about professional skills, okay, and creates a job assignment. Okay. So you have professionals, right? And professionals, well, how they contribute? Well, they basically give information about the skills and availability to this process. Okay. So this process assigns jobs to professionals and creates reports to managers. Okay. Questions? This is one example, so you will see several examples of those. So this is called level 0 DFD. Okay. Say it again. Okay, so it looks very complicated, right? When you look at this and you think, well, how would I make one? Okay, so the answer is, well, it's more of an art how to make one, but there are some guidelines. And if you follow those guidelines and you understand how business operates, it's not that hard to make it, okay? It will definitely take some time to figure it out. But today we'll have, 2 comprehensive examples, so you will see how it's done. Yeah.
So for the project, we're going to step 7, and the level 1 is level 0 for this, or the
Yes, level 0, not level 1. Both context and level 0. So again, we'll discuss how there are. So I gave you printouts, okay, basically guidelines. So we'll talk about this, and you will just follow these guidelines. So most things that are here come from these guidelines. You don't even have to think a lot, okay, how to do it. Some are not. Some you have to, put your imagination into place. But again, at this point, you just need to understand what's going on, okay? I think, and then we'll try to design those, okay? And we'll look at examples how to do it. Okay, good. So then you have a level DFD diagrams, right? So level 1 DFD diagrams. So those DFD diagrams are more detailed, okay? You further decompose processes into smaller sub-processes, okay? For example, you had this, what was this? Record job, right? Well, or assign professionals, I'm sorry. No, I'm sorry. So let's look at this assign professional, right? Level 1 DFD is when you look inside, well, what's happening there, right? Let's look in more details into this assign professionals thing. So here's the level 1 DFD for assigns professional. Now we decompose, okay, this assigns professional process into 3 sub-processes, right? Well, first you have to check skills of your professionals, right? Then you have to check whether they are available or not. Finally, you have to make assignments. You have to assign them for some job, okay? So you have a process which checks professional skills, right? Looking at jobs which need to be added, right? And then you have a process which checks availability of professionals, right? Maybe professionals, maybe you have professionals with skills needed, but they are on some job, and you don't have anyone to assign, right? Finally, you make assignments, right? So if everything is fine, you make assignment. So first you check skills, right? So you have an order, you have a job. So maybe your firm is not in position to do such a job. Maybe you don't have employees with such skills. So first you check skills. Then supposedly you found someone with such skills, okay? Some employees, professionals, I'm sorry. Then you check whether those professionals are available. If at least say one is available, you assign them to the job, okay? So what are external entities here? So you have professionals, right? We want to check skills, and we want to assign them jobs. You have managers, for which you create reports, right? So these are the same entities, right? Agents which were related to this assigned process, assigned professionals 2.0. So those entities are the same, right? We just drill down, basically. Finally, what tables do we have? We have a jobs table, right, which is accessed all the time, and we have professionals table, information about employee, and we have information about their skills, and we also record information about job assignments here. So, questions regarding this? There is two mistakes here, actually, in the book. So there is a mistake here, and I can tell that such system wouldn't work. Okay. So you have three processes, right? And you have those data, right? Again, those arrows basically show you the flow of information. Okay. So here you access the table, right? Here professionals share their skills and availability. Here you access what current jobs. Here you access information about current professionals, right? So all those arrows, again, data flow, right? So that's why are called DFDs, data flow diagrams. But it wouldn't work. So can you see a mistake? Can you see a typo? Here, anyone? Let me give you a hint. So let's say 2.1. So first we check skills, right? So we have a job, right? And we want to check whether we have employees with the same, with some skills. And suppose we did it, right? We access professional skills, and we found out that those skills are, well, we have some employees with those skills to do the job. Then what? What would you do then? Yes?
Check availability.
Yes. So, but how do you check availability? Again, suppose you want to, you want to kind of automate this. How would you do this? How do you imagine this in your head?
Going down.
Going down. So, okay. So first, I think one easy way to think about this. Well, you have all your employees, information about set of all employees, and in each step you kind of filter them out, right? First, you filter employees with the skills, then you filter employees which are available, right?
I don't know why it's going from assignments up to check skills. So it would check skills before it made assignments.
Right. So first you check skills and availability, then assignments, right? And there is some sequence here, okay? And you would think that, well, if you want to check availability, right, you do it after checking skills. So you have to get information from this process, okay? So those are not linked. They shouldn't be linked. Basically, you have a system which has only inputs, right? Only inputs, no outputs. This is a mistake. Whenever you have a process always has inputs and always has outputs, okay? So the correct way would be something like this. First, you check skills, right? Information about, well, say, employees which have sufficient skills would be written to a special table called check skills. Then check availability. We'll read this information from this table, okay? We'll check whether those employees are available, so those professionals are available. Write information to check availability against some special table for this process. Finally, there'll be another process we'll pick randomly, for example, and professional, and would assign them to a job. Okay, so very important here is flow of time. Okay, and the sequence of processes. Each system should have some output, and if you have, several processes which are connected, okay, an input of one process should be an output to the other one. Okay? This is the idea, or more or less, or at least output to one should be input to the other one. Questions? Guys, any questions? Good, good. So this is level 1 DFDs, and by the way, look at the naming: 2.1, 2.2, 2.3, right? Here we had 2.0. Now we kind of go further down, one level down, right? Level 1, 2.1, 2.2, 2.3. So I won't make you do level 1 DFDs, so you will have to do level 0 DFDs. Okay, this is for your assignment. Good. So how do you create a DFD? Yeah. You will have to do a context diagram. You'll have to do level 0 for recorded information. We'll talk about this. You'll have to do level 0 for maintaining information. And you will have to do level 0 for reporting. So you'll have to do 4 DFDs in total. Okay? Yeah, so level 0 incorporates 3 DFDs. Okay? So it's not just one. Okay? So I'll talk about this. So how do you construct those? Again, so this is one guideline for constructing DFDs, and we'll talk about others. So basically, we'll talk more specific for each type of DFDs. But anyway, so first you have to understand what the system does. Okay? What is the scope of the system? What it does and what it does not. Then you want to see what are the processes, right? So you can have, like here, you can have 3 processes. And you want to see how those processes are related. For example, all those 3 processes are related, and the mistake was not to relate them at all. Okay, so we corrected this mistake. We related them through those 2 tables. Okay. Then you want to see, what tables, what information do you need, right? You need information about professionals, professional skills, jobs, and so on. So you want to think, what tables do you need? You also need tables where you would write results of the processes, right? So, well, running ahead. So we will have, for each of those processes, you will have a table of its own. So we'll discuss this, but just for you to, to keep track of those things. Okay, so where you write the results. You need to label all of them, right? So if it's 0 DFD, it will be 1.0, 2.0, 3.0, and so on. If it's level 1, we'd say 2.1, 2.2, 2.3, and so on. Okay, and if possible, you have to do everything neat. Okay, you don't want those errors to overlap. Oh, by the way, look, here are 2 errors, right, which overlap. So what you do, you have this kind of, convex line here, right? Because curve, which basically indicates that, this is the continuation of this arrow, okay? So please note this. Okay, good. So basically now you have at least some understanding what are EERs and DFDs, okay? Now the question is, well, you asked me, so how do we create those, right? How do we design those? And that's why I gave you those guidelines, right? Which you have called REA. There is, a very famous, actually, well, a Cotton professor, okay, in Michigan State University, and he designed this REA thing. Okay, so those are basically guidelines how to approach this problem. Okay, how to design those EERs, and then DFDs are based on EERs. Okay, and basically so the idea is very simple. So when you think of a business, what makes business possible? What do you think? Money. Well, in I don't know, some time ago in ancient times, you could argue that there were no money, but there still was a business. Okay. So what makes business possible? Supply and demand. Why do you have supply and demand? Okay. An idea. Well, not really. Well, idea is also kind of business, but that's not what I'm talking about. Something that you learn in economics class. What makes business possible? Why do we have business at all? What is common to all business? Yes. Profit. So you make profit. Okay. But how do you get this profit? Sell something, right? Okay, this is better. So you sell something and probably buy it. Well, anyway, but what does it mean that you sell something? And again, suppose there are no money. I think money confuses you. Suppose we live in ancient times. There are no money. Okay, so how did society evolve? Why communities established? Say that again? Borrowing. Closer. Okay. Trade. Great. Yeah. So there is some trade. There is some exchange. Okay. There is some exchange. For example, so Woodley here. So suppose he can, make some great tools, right? We live in ancient times, so he made great axes, right? I need axe to chop trees. Okay. Yeah. And I suppose I'm a farmer. I can farm something, right? I know how to grow food. So he is better at, making tools. I'm better at growing food. So there is something called utility, right? So this is something easier for me, and I will get utility, right? Economic utility if I trade with him. Okay, I'll give him some food, he'll give me tools. Through this economic exchange, okay, taking place. So economic exchange is what makes business possible. But what do we exchange? Commodity. Okay, commodity. What is a commodity? Well, one way is to think of commodity. Okay, what is a commodity? Commodity is something what? Two characteristics. Well, not tangible, but what did you say? Of value. So this is something valuable, okay, and something what? No, I mean, oxygen is valuable and necessary. You don't trade it, right? So what should be the other characteristic of a something, commodity or something? It should be what? Well, it's of value, and it's not just of value. Again, oxygen is of value. Water is of value, right? You don't have much problem with oxygen or water, at least here. It should be what? Resource. So I think we're trying to say that it should be scarce, right? Yes. It should be scarce, right? So there should not be a lot of these things. So this is called a resource. A resource is something valuable and something scarce, right? So otherwise, under a resource. So the idea is that business trades resource. Okay. So when you but it's not that that you have resource. There is some trade, right? So there is something going on, and this something what's going on is called an economic event. Is when you say trade resource. So any exchange in resource is called an economic event. Okay. So the idea with this REA is basically to think about resources, right? Think about events that basically, result say in this trade or something, and agents, basically participants. Okay, say people who participate in this exchange, in this economic events. Okay. Plus, there are other events which are not non-economic. For example, a customer makes a call, right? It records information, so this is information of a value, but there is no exchange taking place. Okay, this is called a business event. So all economic events are business events. Okay, they are, they somehow are valuable or not to business, and then there are business events which are not economic events. So the idea is to look at business events, resources involved, if any, and agents who are involved in these events. Okay. So actually, just talk about this, all of this, right? So resources is something which is valuable and which is scarce, right? Then you have economic events which result in exchange of these resources, and you have agents which participate in those economic events. Okay. So if you look at first letters, it says REA, resources, events, agents. And we'll talk about REA methodology, resources, events, agents methodology. Okay. So the idea is to think of a business from the perspective of resources, events, and agents. Okay. This is what we'll be doing with this REA methodology. And this is how we will build EERs and DFDs based on this, using this kind of thinking. Okay. So it was, as I told you, this is Bill McCarthy. He is a professor at Michigan State University. So he developed this REA, actually a close friend of Rutgers. So, and the idea is that, well, first you look at it, well, you have a business. So first you try to think of what business events are important to this business. What are the business events, okay? What are business events? Then you think, well, okay, we have such business event. Are there any resources associated with these business events? If so, what are those resources, okay? Then, okay, so who participate in those events? Those are called agents, and so on, okay? An important part here is to determine whether a business event is, significant or not. So there may be some business events which are of minor significance, which you don't want to model, right? If you think about an accounting information system, the idea is to capture information and somehow to model your system, to model your business. But world is very complex, so you cannot model everything, right? So the idea is what things are significant and what are not. So here's the definition for what is significant. So significant business events are those events which management plan, carries out and evaluates, and basically wants to get some reports on those. Okay. If something falls into this category, this is called a business event. Okay. So business event is something that management plans, carry on or executes, and well, evaluates and also gets results from, right? So this is significant business events. So I told you it can be economic, non-economic, they can be internal. So if events are inside your business, okay, so internal to the business, they can be external when you deal with customers, suppliers, shareholders, and so on. Good, good. So, so here how well it would look like, okay. So we'll create REA, well, those EER diagrams, something like this. On the left side, we will have resources. In the middle, we will have events. On the right side, we will have agents. Okay? So resources is something valuable, something scarce. Okay? Events is those business events which usually, result in decrease or increase of a resource. Okay? Agents are participants in those events. Okay. So what's interesting is that, well, if you look at the relationship, right? So relationship are, usually have this kind of relationships between them. Okay. So relationships are in relationships in a way. Okay. Why? Well, for example, you sell inventory, right? You sold some inventory, well, and then you have to increase the inventory to sell more, right? So you have to refill it. So there can be some relationships which will be in relationship because of that. So one relationship with the resource will decrease the resource, other will increase it. Okay. The same goes with events, selling and purchasing, right? So they are called events in duality. So they are dual, since one results in increase and other one results in decrease of some resource. Okay. So this is the idea. Anyway, let's before we talk about REA in detail, in steps of REA, let's also discuss what are business events versus information processes. So business events are events which create information. Okay. for example, so business events are events that create information. Okay. For example, someone placed an order. Okay, this is a business event and it creates information. You know, somehow, well, something happened, right, to the business. So a new information is created. Information process is something that it doesn't create information. It just captures information, okay, processes it, and it reports information. Okay. So it captures information, processes information, and reports this information. Okay, so information process by itself does not create information. For example, you can have an accounting system which would, well, record something, right? Record a sale. This sale happened not due to the system recording it, but due to business event of a sale. Okay, sale happened. Okay, so new information was created, and then you have information system which records this information. Okay, information was not created by information processes. So you have business processes, or also called business events, and you have information processes, or also called information events. Okay, so business events create information, information processes do not create information. So this is a distinction between them. This distinction is sometimes vague. Okay, so it's very hard to say. For example, you go online, you see something that you like, you place it in your cart, and you place an order. Okay, then this order is processed by, you know, this store backend system. Okay, and it's recorded. Then, you know, a shipment is created, and so on and so on. Well, you know, then there are a number of events that has happened. Okay. So the question would be to you: what is a business event here, and what is or business process here? What is an information process here? Business process or business event is something that creates information. Okay. Information process is something that you know, records information, manipulates with this information, and reports information, right? So just make a guess.
What's the question?
An example. You go online, right? You go to an online store.
Mm-hmm.
So you see something like that you want to buy. You place it in your cart. Okay, you buy it. You place an order.
Okay.
Then you have a backend system of well, those store backend system. Okay, which records this. Okay, which processes basically, you know, creates shipment, and creates invoice and all this stuff. Okay, and which executes the order. So here at this point, what is a business process? What is an information process?
So the information process is, I guess, the credit card company taking the money from your account or processing the online payment.
Okay. Not just that. Actually, so here's, yeah, so here's very hard to say what is what, right? But basically, the idea is, when is information created? Information is created when you place an order at this time. So everything before you place the order is a business event, right? Before you actually click it. Once you click it, so, you know, once kind of event happened, okay, you created new information. So then everything else is, say, generating a sales invoice and creating shipment and whatever. This is all information process. Okay. At this point, information is not created; it is rather recorded and processed. Okay. So this is the idea. And you can read some more examples in the book, although not too many of them are in the book. Okay. Good. So why it's important? It is important because when we have EER diagrams, right? In our EER diagrams, we want to capture significant business events, business processes. On our DFD, we want to capture how information is captured, processed, and reported, right? So we capture this data flow, right? So we want to capture information processes. So EERs are responsible for business events. DFDs are responsible for information processes, okay? So this is the idea. And sometimes you can argue that, something is both business event and information process, okay? Maybe we'll give you some examples along the way. Okay, so how do we create EER diagrams? So what are the guidelines for EER diagrams? Well, the idea is that first, usually you would have some description of a business, some narrative of a business, right? You look at this narrative, you try to understand the business. So first thing that you do, first you try to identify the key business events. What are significant business events, okay? What would managers would want to plan, execute, and evaluate, okay? So now suppose you know some events, business events, so you identify them, okay? Then you want to look what are the resources associated with this business event. What are resources here, okay, which are related to this business event. Then what are agents related to this business event. Then you want to identify all the relationships between all entities. And entities are events, resources, and agents. So events, resources, and agents are called entities, right? So first you identify events, then resources, then agents. So you have all entities now. And now you want to identify relationships between them. Whether there is a relationship, whether there is no direct relationship. And once you have this, you want to specify cardinality and optionality. Okay? So put those crowbars or lines or those bars or those circles. So this is basically kind of a guideline how you construct EER diagrams, okay? This is REA methodology. And you will see some examples how to do this today. Okay. So, but before we do this, let's quickly talk about DFDs. So what are DFDs? DFDs are those logical models that capture what? That capture information processes, right? DFDs capture information processes as opposed to business events, okay? They try to model the data flow. That's why they're called DFDs. And there are three main processes. Recording, when you record the information. Maintenance, when you maintain your tables, right, your information. And finally, reporting process, when you generate reports to management or users of account information. Okay, so three types of DFDs. Plus, there's a context one. So there's a context diagram, which is this overview of the business, right? High-level diagram, and then there are three types of DFDs: recording, maintenance, and reporting. So, what is recording? Again, recording is something which wants to capture how data is recorded. Okay. And here are the rules. So basically, when you will do your stage 1 project, you have to follow these rules. Okay? Look, so you do DFDs after EER. So the hardest part probably is to construct EER diagram. If you have the EER diagram, then it is slightly easier. Okay? So when you have EER diagram, you have those events. Okay? So remember, we have events, we have resources, we have agents. So first you look at events in your EER diagram. So each event would have its process, DFD process, the circle, right? So for each event, you will have the circle, this process, okay? Then, so each agent associated with this event should have a table, okay? I'm sorry, should be an external entity, plus should have a table, but tables are later. So each agent are people who participate, right, in business events. So each agent should be denoted as external entity on the DFD diagram, okay? So first you have events. You create a circle for each event, business process, information process for each event. Okay. And then for each agent associated with those events, you put them as external entities, as those rectangles on DFDs. Okay. And what? Once you have this and this, you for each agent and resource you create a table. So for each agent and resource you create a table somewhere. Okay. And you link those tables to your processes, business processes. Okay. Finally, so you have those events, right? Those processes. So you should have what I told you, right? I have this correction. So for each event, each event should have its own table, where you record the information about the event. Okay. So again, the idea is that you have EER. You look at your EER, you see business events. Those things in the middle, right? Those are events. For each event on the DFD, you create those things, so information processes, right? For each of those events, you look at the entities, agents associated with those events. For example, here professionals, so you put them here. Okay. Then what? Then for each resource, like professional skills and agents, you create a table. So you will have a table for skills, you will have a table for professionals, for jobs, and so on, right? And you connect them, of course. So you will try to think, well, how those resources, tables, and agents are connected to processes, right? Then, for each of those circles, you also create a table like this: check skills, check availability, and job assignment, right? So each process has its own table where you record information about this process. Okay. So this is kind of what are your guidelines, right? This is what you have to do. Another guideline, as I told you, the sequence is important. So when you do this, look at the sequence, right? And so if check availability goes after check skills, right? It should be connected, usually through a table for a process check skills, right? So you record information about check skills in the table, and then you use this table as an input for your next process in a sequence, check availability and so on. Okay. So basically, have these guidelines, and these guidelines, they simplify your life a lot. So you just more or less follow them, and you look at the examples, and you try to think, well, what those things, I should put them, right? How all of them are related. Okay. So let's go back. So those was recorded DFDs, right? Then there are maintenance DFDs. The idea for maintenance DFDs is that, say you have tables, or say for inventory, or for employees, or for customers, and you have to maintain those tables, right? So you would say want to add new customers, or delete, old customers, or would like to modify customers, change of address, something like that. So you should maintain information, okay? And maintenance DFDs are DFDs designed for those maintenance operations, okay? So 3 types of maintenance: add, update, delete. Okay. So and now again, so here I put you how you should do it. If you have an agent, okay, if you have an agent, you would have a process, something like maintain agent table, whatever, maintain employees. Okay, you would have a data store which would be associated with this agent, say employees, and you will have another agent, say managers, which would maintain the tables, right? Managers can hire new employees, or fire employees, or maybe modify information about employees, right? So you'll see examples, but again, if you have a resource, right? So for resource you have to have again some agent which would be the process of maintaining a resource agent which will be responsible for maintaining this resource, and you'll have to have a table for resource. So maintenance basically those DFDs are the simplest thing. So you didn't really think much about it. So when you create those, very easy to do. Okay, you don't have to create. Just follow these lines. So for each resource and agent, you should create a DFD. Okay, you maintain information about your resources and agents. Okay, so employees, customers, right? Resources, say cash accounts, right? Or well, employee skills and so on. Finally, reporting process DFD. So reporting are those DFDs where basically you think of which reports should your system generate, and you model them. Okay. So how do we do this, right? So have reports. There may be all kind of reports. There may be standard reports and be non-standard reports, right? But how do you create a DFD? So again, ideally for each entity, what is entity? Again, entity is a resource, event, or agent. You create at least one DFD. Okay. So for each entity, again, you'll see it. You create at least one DFD to report information about this entity, right? For example, you want to have reports on your customers, on your sales, purchases, employees, and so on. Okay. So this is also not very hard to do, but you just have to think of reports. And again, to save the time, you'll see examples how to do this. So anyway, here's this full REA guideline. Okay, the steps in REA. So first, we have 5 steps we already discussed. So first, you identify significant events. Okay, yes, question. Say it again. So am I going to? Yes, yes. I am going to go over the project. Done. So anyway, so here's REA. Okay. By the way, this slide is in different color, right? I'm not sure what color it is here, since you know you have this projector, right? So it should be pink or something. So anyway, the reason why I changed the color of the slide is because I really wanted you to to see that this slide is very important. This is the most important slide in this course. Okay, the most important ones. So how do you design a kind of information system, right? So you use REA methodology. Okay. So first, you have something about the business. Okay. So try to think. Okay, what are significant business events? You identify them. Then you identify resources, agents. Okay. And then you want to identify all the relationships between entities. Entities are resources, events, and agents, right? Okay, so you do this. Then you specify optionalities and cardinality, okay, for each relationship, identify in stage 4. Then you identify attributes of REA entities, okay. Then you identify the DFDs, information processes. Finally, you design data repository, and implement the design. Okay. So, in this chapter, we basically talk about these first 7 steps. These first 7 steps is your project stage 1. Okay. This is what you will have to do for next time, for next Tuesday. Okay. And we'll see examples how to do this. And then you will also do 8 and 9. We'll talk about this in another chapter. Okay. So example. So all of you have this example for student registration processing, right? Please take 5 minutes to read very carefully this case. Basically, it's a narrative of business. Yeah, I'll give you a copy. Okay, so please take a very close look at this. You also need one, right? You're welcome. Okay, good. Just one moment. Do you need one? No, it's So it is on the second page, right? So you have this REA. You turn down the pages and it will be on, well, actually this is the page number 4. I'm sorry, page number 4. Okay, so, no. Oh, actually this is the last page. So we'll have two cases. So so your stage project will be very similar to this. So you'll be given a case. Okay, I'll show you the case, and you will have to carry on this first 7 steps of REA. Okay. So and I'll give you 2 examples how to do this from the book. So this is the first example, student registration process. So please take 5 minutes to read and understand the business, how it works. Okay. Student registration processing. Last page. So all of you have this REA, right? Those papers. So at the very end of REA, there are examples. Okay, let's go. Okay, supposedly you have read it at least twice. So now you have this REA, right? You have those steps, 1, 2, 3, 4, 5. So basically you want to follow each step after 7, right? So the first step is to identify significant events. What is happening, right? And those events actually should be high-level events. So what do you think? What are significant business events here?
What's the question where?
These significant business events here.
Which step 1 through 7 is for phase 1?
Stage 1, yes, 1 to 7. Registration. Okay. I'm sorry? Right, so you look at the slide, right? So anyway, you want to look and know what is the big picture, right? So the big picture, well, the authors of the book identified 2 events. You can identify more, okay? but at least 2 here. So what are those 2? One is course offerings of courses, and the other one is course registration. Okay? Yes. Well, basically the first paragraph is about course offering, right? So I think they give you a hint. Why not? So well, course offerings is the first. Okay, so what do you think? What is a significant business event?
Registration, because you're actually registering for class.
Okay. Okay. But you also have to offer courses for registration to take place, right? Well, you can argue, okay, you can say 1, 2. Actually, I think at least 2 here. Actually, you can think more, right? For example, billing or whatever. You can think of more things, but let's stick with those 2, right? So courses and course offerings, right? Then again, you want to think about what? What do we do next? We follow REA methodology, right? So what is step number 2? Identify resources, right? So when you read again this narrative, the only resource that they mention, well, maybe you can again think of more, definitely. But what they mention explicitly are courses. You can have, but which is not here. You can have basically, well, so for course you have to pay, right? So you can have cash, for example, resource, or again you can have skills, right? So you have faculty that teaches certain courses that have certain skills, right, and so on. But here they talk about courses. So therefore, here we have the courses. Then we think about agents. Okay, so definitely students, right? Registration, and for course offerings, well, they mention department and they mention instructors. So you have to put at least those 3, right? Maybe you can put more. Maybe you could have put university instead of this, so it will change the thing. So what I'm getting at that, well, this is more of an art. I'm sorry? Well, say skills, instructor skills can be resources, or the knowledge or whatever, okay? So, for example, in the accounting department, you can have 5 professors that teach financial accounting, 2 that, managerial accounting, 2 information systems, and say 3 that taxate, well, whatever. So you can think of it. But this at this point, again, if you look at this, it doesn't mention anything about skills, right, or knowledge of instructors. So we don't have to model this. Say it again. But this is also resources, right? So we had before professional skills. So this can be an attribute and also a resource. So it depends. Again, this is an art. Okay, so this is where you have to put more, put a lot of thought. What are events? What are resources? And what are the agents? If you figure this out, then the rest thing is more or less trivial. Well, not trivial, but okay, it's much easier. So I think this is the hardest part, to identify events, resources, and agents. Okay, so suppose you have those, right? Then what do we do next? We have to model relationships, right? So for each entity, and all of these are entities, we have to model relationships, right? Okay, let me show you. So basically, we have this many relationships, right? So we have relationships between departments and, say, instructors, right? So instructors are employed by department. Instructors are assigned course-to-course offerings. Courses are offered through course offerings. Registration are for course offerings. Students register, do the registrations, right? And what else? And students major in department. So actually, this one major in, the name mentions this in the case, right? So this is not something important, and if you wouldn't put it, no big deal, okay? But all other stuff, more or less, should be here, okay? So you create those diamonds, right? When you have those diamonds, you have to do what next? When you have these relationships, you have to what? Again, you have methodology. What's the next step? You identify relationships between your entities, right? Then you what? And then you have to specify the optionality and cardinality. Okay. So basically, you have for each of those, for each of this link, right? For each relationship, you have to put, those notation, those what we discussed today, crossbar, those bars for mandatory relationship, and circles for optional relationships, right? So again, so here, they put everything for you. But let's take a look. Let's try to think if we can decipher. So we have department and course offering. Okay. So what is the relationship between department and course offering? Yes.
Course offering has to be.
No. Well, first we say departments and course offering are in relationship one to many. Okay. So we say one to many, and well, basically say mandatory one, mandatory many. Okay. Okay, so let's first this one. So again, let's not rush it, right? Still have some time. So how do you read this? For this one? This one? No. No. You don't start with department. You start with the opposite.
Course offerings.
Yes, a course offering
Must have one department.
is offered by
One department.
exactly one department.
And then
What?
one department.
Exactly one, so it's mandatory one, right?
Yeah.
By department and exactly one. Or
Then one department can offer many or one course offerings.
yeah, department can offer one or many course offerings. Good. What about courses and course offerings? Stan, please, what is the relationship between courses and course offerings? Sorry? Why not? So why don't you ask a question? So is it one to many, many to many, many to one? So again, let's look at this. So we have courses, we have course offerings, right? On the courses side, we have a bar, means mandatory. We don't have a crow's foot like this, so it means one. So it's mandatory one. On this side, we have circle, optional. And we have cross foot, many, optional many. So relationship between courses and course offerings is mandatory one to optional many. Okay? Yeah. So yes, and so this is basically okay. Yeah. Let's stop here. So again, courses and course offerings. So courses and course offerings is a one-to-many relationship. Okay, it's mandatory on the courses side and optional on the course offering side. Okay, so this is a very rigorous way to call it. So now how to explain this, right? So what does it mean? So we have to explain this side and explain this side. Okay, so let's first explain, say, this side with optional many. So how do we read this? Okay. So, Deji, so okay, so how to read this? So please read this. Optional many. Okay, but what does it mean?
One course may or may not be offered many times. There might.
Yes, Ngozi. What? Either no course offerings or many course offerings. So it's not a full sentence. Guys, okay. Again, let's forget about this offered, right? Instead, say associated, okay? I think it's easier to think offered, not offered, offered by. Let's say associated. So if we read this, we say a course is associated with either 0 or many course offerings. Okay? Now let's look at this. Again, start from the opposite, right? The opposite is course offerings. A course offering is associated with exactly one course. Okay? So this is a way to read this. You have to practice this, okay? Okay, let's look at course offering and registration and students. Okay, let's put it this way. So,
Registration must be made by one student.
registration, let's say, is associated with exactly one student, right? This one. How do you read this part of relationship? Each student, or a student, right?
Is associated with either 0 or 1.
Or one register. Yes, exactly. Okay, either 0 or 1. Not exactly, since there is no bar here. It's optional, right? Participation. Okay, so this is how you guys practice this. Okay, so.
A student can be associated with either 0 or a student can be registered but not registered.
Yeah, you can put it this way. Okay, so basically, so why is this so? Why? Okay, in what case does it make sense? What do you think? Let's think of this: students and registration, right? So here, this means that a student can, can be associated with one registration, with either 0 or 1 in registration, right? So he may be or he may not be registered. If he's registered, he can have only one registration, basically, right? So, does it make business sense or not? What do you think? Does it make sense? Well, anyway, when I ask you this question, right, and we'll have a lot of those questions. So you have to think whether optionality makes sense and whether cardinality makes sense. Okay, so optionality here means that student can be or cannot be registered, can have or cannot have registration. Does it make sense or not? Why? Summertime, right? Summer course. Not everyone is taking summer courses. Good. Now, student cannot have more than one registration. Okay, so cardinality here is 1. No crosswood. 1. Does it make sense or not? Good, good. Say it again. No, look, courses are different, right? So you can have one registration for many courses. So each registration should have at least one course, possibly many. It does make sense when? No, it makes sense when you want to change your mind. Okay, when you want to re-register for a course, you don't want to take this course or whatever. Okay, so for example, at Rutgers we have here optional many. Okay, so for example, you registered for some course and you decided, well, I don't want to take it. Okay, so you can register. You can have another registration. Okay, so this is one thing. So let's continue. Don't have a lot of time. So please take a close look at this at home, right? So try to understand each of those. Okay, it all makes perfect sense. And try. Well, yeah. So actually, in this example, everything makes perfect sense. Think why they put optionality once they or cardinality, right? Why we have here say 0 or many. Okay, quick question. Why here we have optional many? So for each course offering, they may be either no registration or many registration. Why is there are no here? Well, why it's optional? Why we can have an example when we have a course offering, but which is not offered for registration. Sorry. Yeah, some courses are not offered in summer. Okay, for example, some courses are not offered in summer, right? Registration, summer registration. So you cannot have this, and so on. Yes. So a course offering, okay. So for a course offering can be associated with either 0 registration or many, or you have a course which is not popular. No one registered for this course. Okay. So you have a course for which there are no registrations. Make sense? Why it's no? So what do you mean it's full? So it's full, then there are registrations. Okay, look, so students have registrations, right? You have registration for 3 courses. I have for 2, right? If we are registered for the same course, this course will have at least 2 registrations. Okay? Not 0. let's talk after the class, okay, about this. I just want to continue this. We don't have a lot of time. So basically, you think about cardinality and optionality, okay? Guys, that's why I told you, read the book, okay? So you won't be able to grasp this from the first time. There should be some practice with this, okay? Okay, good. So you have these entities, right? You have relationships between them. You have optionalities, cardinalities. Good. What next? Guys, what is next? Attributes, right? So it's not here. Basically, you would have. This is what you would have to do. You would have to have those attributes, right? As on ER diagram. So they didn't show it here, but this is something what you have to do, right? So you would have to have something like this. For each entity, you will have attributes, okay? Good. Good. So then what? What is next? Information processor. DFDs, basically. We want to make DFDs, right? So first you make a context diagram. So here you have a system. It has inputs and outputs, right? So you have external agents, students, instructors, departments. Students request registrations. You have instructors who have course requests, and you have departments who supply some course section data, right? Then students are given schedules, the P statements, and instructors are given assignment, class, and departments are given class rosters, right? So this is kind of a high-level view on a system. Yes, Myra?
I'm just trying to take it all in.
So you think of your information system like one system, right, which has inputs and some outputs. Okay. So and those are inputs and outputs. Yes. Some things okay, guys. So where do you get all of this, right? So for example, relationships. Some relationships are explicitly explained, okay, in the case. For example, if you look at the case, right? So it says, each department can offer many course sections in a semester, right?
Yes.
So it explicitly said that here you have many course offerings, right? Okay? Some things, is here explicitly. Some is not. Some you have to think, okay, what will make sense and what will not make sense. Okay? Steven, is it clear? Yomira, is it clear? Good.
Yeah.
Okay. So this, for example, they made up. So you may make up some relationship. Okay. So not everything is described in a narrative. So you have to create some. Okay. So then you have a context diagram. Where did they get this? Again, many things are in narratives, right? So you say, well, you have students which want to have registration, right? So they have to have some input in the system, right? How does they get registration? Well, how do you get registration? You go to a register office and you make a request, right? So does it make sense here to have this input or not, guys?
Does it make sense to
Make this input, to have input from students, which is a registration request, right? Good. Okay. So this again, they made up this, right? You may not or may not put it, so it won't be a huge mistake if you, for example, didn't put this. Okay. So if you read the narrative, it's nowhere there. Well, but you may come up with this. Okay. It's, again, your imagination is more of an art than some You see, in accounting, you're used to these exercises, right? So you have exercise. Well, what to do? Well, you have some clear instructions. Here, well, you are a designer. Okay, so some things are clear, some are not. Some you have to make up. Okay, I can teach you how to do this. Okay, so it's come with practice and experience, and it depends on how creative you are and how you understand the process, business process. The same for departments, right? Well, actually, okay. So in order to students to register, right, they it should be some course offerings, right? So departments provide course offerings, okay? Makes sense. Then again, they talk about schedules and fees, right? So you get this from here. It says students get schedules and students get fee statements. Great. Assignments, maybe they made it up, maybe it's here, I don't remember. Finally, it says about class rosters. I think they do mention here. So, you know, you read the narrative, you try to understand well, and what's going on, and this is what you try to put in, okay? So this is something hard, okay? Yes, you have to, you know, to put some thought into it. Yes, yes, yes. This is your first stage. Yes. Then, this was just context. Now there is 0 DFD. So there is 0 DFD for recording process. Okay, guys, 0 DFD for recording process. So again, you follow those steps, right? Which were on the slides. For each business event, you create information process, like here, those 2 circles, right? We had 2 events, so 2 circles, right? Then what? Then for each agent, you create, you know, this external entities, just like here, departments, instructors, and students, right? Then for each agent and each resource, you create a table, again, just like here, right? So you follow all of this. Then, what I told you, you have to look, you have to create those tables for each process. So you want to record results of each information process. So for each process, you create a table, okay? Then what? Then, again, something important, which they don't talk about much in the book. Business processes are related. There is a sequence to them, okay? So you want to take this into account, okay? So that's why they connect, okay? Again, you follow just those basic instructions. Good. So,
So our project is the library, right?
no, no.
What slides, I should say? Because you said we're just doing 0.
Yes.
So
So it is some of the slides, so guidelines how to do this. Okay, so you look at recording, 0 DFDs, and there are guidelines how to do this. I put them on the slide, plus in the book. Okay, those are maintenance. So you want, for example, there should be more, but you want to maintain each resource and each agent. Okay, so what are resources? Resource is courses, right? So you want to maintain courses. So you have a process, you have a course table, you maintain it. By the way, here's a double-headed arrow. So you modify it, right? You add, you delete, modify it. So please take note of this. Okay, and department do this maintenance. Then you have departments and students maintain a student table, right? Department can hire, well, basically enroll students, right? Or delete students, and students can update their information. Okay? So those are easy. The hardest part, I think, is ER diagram, and well, maybe recording, but still, you know. The hardest part is for you to figure out this diagram. Then it gets much easier. So there is another example, which we don't have time to cover, but it's in the book, so you can take a look at those, and it's also in the slides. Now let me briefly show you the assignment, okay? So please stay for 2 minutes. 2 minutes. That's all I ask. So you go to the Blackboard. There is assignment tabs here. Assignments, right? You go to assignments. Then you have project stage 1. And you have submit project stage 1. This is description of the project, okay? Project description. This is where you will submit your files. First of all, you will create EERs, DFDs, right? You will bring them to me in physical copy, and you will also submit an electronic copy, okay? And there's a due date. So let's look at the description very quickly. Description is basically this, well, similar to what, well, you've seen, right? So this is a case, a narrative, and you just read the case, you try to understand it, right? And you know, there's not much, so it's a, you know, small case, nothing complicated. You read the case about the business, you try to understand this case, okay? And you create, and it says, well, basically it says to create a ER diagram, right? Prepare a context diagram and level 0 DFD. Okay, so you should have level DFDs for all these processes. Yes, yes. No, those are recording. It says, right? It's labeled. Okay. Yes, so you have to have 4 DFDs, 1 context, 1 level 0 DFD for recording, 0 DFD for maintenance, 0 DFD for reporting. Plus you should have ER diagram. Okay? This is your assignment. So you have a week, so I think it's more than enough time, and you don't have a lecture next time, which is maybe good, so you can concentrate on this. Okay, so you have to submit it electronically. What else about this? Well, basically that's all. Okay, yeah. Yes, if you work in a group, you submit just one work. Okay, on behalf of a group. Yes, regarding solution. So there is no correct solution. So I expect you to have different solutions. If we see the same solutions, this is something is fishy. Okay. So again, each people are different. We'll make different design, different choices. Yeah.
Is it only that we have to stay till 10? Or do you want us to stay to 10?
Well, it depends.